Today's lesson is going to begin our polynomial unit. A polynomial is an expression that has many terms. It could be one term, two, three, four, however many. Terms are usually separated by plus or minus signs, and so look for your plus and your minus signs to distinguish how many terms that you have. Examples of polynomials could be just a plain number written by itself. It could be positive or negative. So 10 could be a polynomial expression. Negative 10 could also be 2x, negative 5y. See, nothing's added or subtracted to those, but we still consider it to be a polynomial. Look at this one, 100x squared minus y. That's two separate terms separated by this minus sign. It would be 100x squared and negative y would be your two terms. This is a polynomial. 11x to the fourth minus 3x squared minus 5. This is three separate terms separated by minus signs. So you have 11x to the fourth, negative 3x squared, and negative 5 as your terms. Altogether, that makes a polynomial. It's important when you are dealing with polynomials to always put your answers in standard form. Standard form is when you take an expression and you put it in alphabetical order, okay? And you always have your largest exponent counting all the way down to your smallest exponent. If you have a constant term, remember that's a number without a variable, that one should always be at the end, okay? So let's go ahead and look at some polynomials and let's put them into standard form. Let's start with number 1. We have 3x plus 1 plus 2x squared. That's 1, 2, 3 terms. So if I'm going to put this in standard form, I want to start with my largest exponent. So I see that I have 2x to the second power. Now you look in front of it. Do you see how it's got a plus in front? So we know 2 is positive. So I'm going to write down 2x squared. Then I'm going to go to my next to the highest exponent, which will be x to the first power. Now look in front of the 3. You don't see anything, so you know that 3 is positive. So you're going to write down plus 3x. The end should always be your constant term. Remember, your constant is without a variable, okay? So we end up with 2x squared plus 3x plus 1. There's 3 terms here with your largest exponent being a 2. You're going to learn in a moment that that's going to be the degree of your polynomial. Let's look at number 3. We have w to the third plus 5w squared plus 28 minus w. That's 1, 2, 3, 4 separate terms. So to put this into standard form, start with your largest exponent, which in this case is going to be w to the third. It's positive, so just write it down. Now after w to the third, look for a square. Always step down. Well, looky there. In front of the 5 is a plus, so we have a positive 5w squared. Now after square, step down to the first power, and we have one of those down here. But look in front of the w, and you see there's a minus sign. So that tells me that w is actually negative. And after the first power, that should be followed by your constant term. Your constant term is a positive 28. And this is standard form, 3, 2, 1, 0. Okay? But look at number 5. We've got A's and B's. Okay? So in order to put these into standard form, A needs to come first. And since you have some with A and B, what you want to do is you want to put AB together and then put B at the end. So it'll be A, AB, B. All right? So let's start with plain A's. I see that I have A to the third power. So we're going to take A to the third power and write it first. Now let's look at our AB's. I've got an AB here and an AB here. Always put your largest exponents first. So that tells me a squared b squared needs to come before ab. Now in front of a squared b squared we have a plus sign, so we know that it's positive. So plus 5a squared b squared, followed by positive 2ab. And that means my b will come back here on the end, okay? So remember, it has to be alphabetical order with the largest exponent first. So we would have A, B, B, okay? So 1, 2, 3, all written in standard form, okay? You are going to do, as part of your assignment, 2, 4, and 6, okay? All right, now let's talk about naming and classifying polynomials. So you've got a little chart right here, and it's going to break it apart into degrees and terms, okay? Now, polynomials are classified both ways. They're classified by their degree and the number of terms that they have. So when you're classifying a polynomial by its degree, look for the largest exponent. The largest exponent will tell you your degree. Now, if you're classifying them by the number of terms, you just count up how many terms that there are, okay? Look for the pluses and the minus signs. That'll separate your terms. Now, when you're classifying by degree, if you do not have a variable, you only have a constant, okay? Then that's going to be a degree 0, and we call that a constant. If your largest exponent is a 1, x to the first power, y to the first power, that's linear. That's degree 1. If your largest exponent is 2, that's quadratic. If your largest exponent is 3, that's cubic. And if your largest exponent is 4, that's quartic. Now, when you talk about terms, remember those are separated by your plus and minus signs. If you only have one term all by itself, that's a monomial. 2 terms is a binomial, like a bicycle, 2 wheels. 3 terms is a trinomial, like a tricycle, 3 wheels. Anything past 3 terms, 4 or more terms, you just call that a polynomial. So let's look at number 7. You see how you only have one term? Okay, since you only have one term, that's a monomial. Now let's talk about its degree. There's no variable, so that means it's going to be a degree 0. So this is going to be a constant because it has no variable and a monomial. So this is the degree, this is the terms. Let's look at number 9. You got 7p plus 1. Okay, the largest exponent is p to the first power. So that's going to be a degree 1. We call that linear. Now notice I have 7p and positive 1. That's 2 terms. 2 terms is a binomial. So we have a linear binomial. Look at number 11. My largest exponent is a 3. Okay, so whenever you have a degree 3, that's a cubic. You have 1, 2 terms, so that is also a binomial. All right, you try 8, 10, and 12. Now the next part of our lesson is actually adding and subtracting polynomials. When you add and subtract polynomials, the only thing that you're going to do is combine your like terms. That's it. Okay, so in order to add and subtract polynomials, you can only add and subtract the ones that have the same variable and the same exponent. So look at this first example. We have this trinomial plus this trinomial. So I can only add x squares with x squares. Now you're probably asking yourself, why did you start with x squared when there was an 11x in the front? We have to write polynomials in standard form. Since we have to write polynomials in standard form, I'm going to start with the largest exponent. It saves me a lot of time and effort. So what I have right here is a negative x squared. That's negative 1. And I'm going to add it to 2x squared. Negative 1 plus 2 is a positive 1. So that's going to give me 1x squared. Now after x squared, I'm going to step down to regular old x. I've got 11x plus a negative 5x. So I have 11 plus negative 5. 11 plus negative 5 is a positive 6. So I'll have plus 6x. x. And then after the first power, I go down to 0, which is my constant term. So I've got positive 13 and negative 23. So 13 plus negative 23 is a negative 10. So I put minus 10. Okay? So this is my polynomial that I get after adding them together. Notice it's in standard form. It's a degree 2, so it's quadratic. It has 3 terms, so it's a trinomial. Now, to subtract polynomials like you see here, what you want to do is you want to change this to addition, okay? So, to do that, you'll change minus to plus in the middle. Then you're going to go to the right side of that minus sign in that parenthesis, and you're going to change every single one of these to its opposite sign. So we'll change positive 7x to negative 7x, plus 3x squared to negative 3x squared, and plus 1 to negative 1. Now we're ready to go. Let's start with our largest exponent, which is square. We've got 4x squared and negative 3x squared. So that's going to be 4 plus negative 3, which is positive 1. So that's going to be 1x squared. Now let's go to regular x. We've got 5x and we have negative 7x. So 5 plus negative 7 is negative 2. So I have a negative 2x. And the last thing I'll do is my constant term, which is a minus 1. So we have x squared minus 2x minus 1, which is going to give us another quadratic because it's a degree 2, and another trinomial because it has 3 terms. Okay, so notice on both of these, again, I've written them in standard form. Do not change your exponents. The only thing that you're going to do is add and subtract the coefficients in the front. That's it. Do not do anything to the exponents. Multiplication and division change exponents. Addition and subtraction deal with the coefficients in front of the variables. Only add and subtract like terms. That is so important. Okay, so let's see what else we can come up with here. All right, let's look at number 13. We've got x plus 5, a binomial, plus 4x plus 7, another binomial. Since there's addition in the middle, we're ready to go. Let's start with our largest exponent, which is going to be x to the first and 4x to the first. X has a coefficient of 1. So 1 plus 4 is equal to 5. So that's going to give me 5x. Then my constant terms are 5 and negative 7. Always use the sign in front of the number. So 5 plus negative 7. That's going to give me negative 2. So I have 5x minus 2. Now, this largest exponent is 1, so that's degree 1, so we know that's linear. There are 2 terms, so binomial, a linear binomial. Number 15, okay, we got plus in the middle again. So starting with our largest exponent, w to the third, that is the only third power that I have. So I'm just going to go ahead and write that down. Now let's go to the second power. I have negative 2w squared and positive 3w squared. So negative 2 plus 3 is a positive 1. So I'm going to put plus 1w squared. Did you notice I didn't write the 1 down? Because we don't need it. It's understood to be there. Just like an exponent of 1 is understood to be there. Now after the second power, we go down to the first power. But as I look through here, I don't have a first power. So I'm going to skip w. And now I'm going to go to my constant terms. I've got negative 5 and negative 11. Negative 5 plus negative 11 is going to give me a negative 16. So I'll put that at the back. So I've got w to the third plus w to the second minus 16. This is a degree 3, so it's cubic. There are 3 terms, so we know that it's a trinomial. All right, number 17, let's do the same thing. We've got plus in the middle. All right, starting with our largest exponent, which is a 2. I've got negative p squared and p squared. This is a negative 1 plus a positive 1. Well, isn't negative 1 plus 1 equal to 0? So if I've got 0p squared, do I have a p squared term? Well, the answer to that is no. Do not write down p squared, because if you do, that means there's one of them, and there are none of them. So p squared is gone with the wind. Now let's move down to the first power. We have 5p plus negative 4p. 5 plus negative 4 is 1p, so I'm just going to write down p. That's it. And then after p, we go to our constant terms. We have 8 and negative 15. So 8 plus negative 15 is a negative 7. So that's going to give me p minus 7. All right, now that's going to be p to the first power, so we know that's degree 1. And degree 1 is linear. We have two terms, p and negative 7, so we know that's a binomial. So this is a linear binomial. Now let's look at number 19. You see that minus sign in the middle? Let's change it to plus. And we're going to change 3x squared to negative and 5x to negative. All right, let's start with our largest exponent, which is x squared. We've got 1x squared plus negative 3. 1 plus negative 3 is a negative 2, so that's going to give me a negative 2x squared. Now after squared, we go to x. We've got 17x and negative 5x. So 17 plus negative 5 is a positive 12. So we have negative 2x squared plus 12x. Notice we have a degree 2 here, so that means it's going to be quadratic. We have two terms, so it's binomial. So we have a quadratic binomial. Number 21, change minus to plus, make 4 negative and 11 negative. So we have our largest exponent is c to the first. That gives me 4 plus negative 4. 4 plus negative 4 is 0. That means you do not have a c term. Do not write down c. That means you have 1 and you actually don't. Now your constant terms are negative 11 and negative 11. Negative 11 plus negative 11. That same sign, so we'll add and take the sign. So this is going to be my answer. Since I don't have a c term and I have a constant, negative 22 is my final answer. That's going to be a degree 0, so that's a constant. There's only one term, so it's a monomial, so a constant monomial. All right, number 23, change minus to plus, make 15, 8, and v all negative. Change the sign of everything in that second parenthesis when you change minus to plus. Now let's start with our largest exponent, which is 2. Okay, we've got negative v squared and negative v squared. Negative v is negative 1 plus negative 1, which is negative 2. Negative 2v squared. Now let's go to your regular v's. You've got 7v and negative 8v. 7 plus negative 8 is negative 1v. Don't write down the 1, just put negative v. That's the same thing as negative 1v. And then your constant terms are 14 and negative 15. 14 plus negative 15 is negative 1. Now this one doesn't have a variable attached to it, so you have to write down the 1 this time. So negative 2v squared minus v minus 1. This is a degree 2, so we know it's quadratic. It has 1, 2, 3 terms, so it's a trinomial, quadratic trinomial. All right, so you are going to finish up 14, 16, 18, 20, 22, 24, 25, and 26. Email me if you have any questions.